Picture a user with full administrator access. Star on every action, star on every resource, and may still get denied. Not because their policy is wrong, but because someone above them, in a different account entirely, quietly lowered the ceiling. In a multi-account organization, the grant no longer wins. So what actually decides? Stack lessons, cloud architect path. Let's work. By the end of this video, you'll know how to give someone access across Amazon Web Services accounts without ever handing out a permanent key, and you'll know exactly which controls grant access and which ones can only take it away. That grant versus restrict distinction is the machinery real organizations run on, and it decides a surprising number of scenario questions. In the last episode, we built the foundation. An IAM role is an identity with no long-term keys. You assume it to get temporary credentials. Everything is default to me, so nothing is allowed until an explicit allow says so. And one explicit deny overrides every allow everywhere. Hold on to those three ideas, because now we're taking identity and stretching it across many accounts at once. 5 terms will carry this whole video, so let's pin them down. Amazon Web Services, STS, the security token service, hands out short-lived credentials that expire on their own. AssumeRole is the call that swaps your identity for those temporary credentials. A service control policy is an organization-wide guardrail that caps what's possible across accounts, and it never grants a thing. A permission boundary is a cap on a single user or role. And IAM Roles Anywhere gives machines outside Amazon Web Services temporary credentials using certificates. Don't worry if those feel abstract right now. Each one gets its own moment. Let's ground this in a real situation. Medicorp runs 2 separate Amazon Web Services accounts. Production is locked down tight, and the sandbox is a loose, poorly governed playground. Now the developers over in the sandbox need to reach some production resources to do their jobs. Here's the tension. No permanent production key should ever leave the production account, because elite key is forever. And these developers must never be able to hand themselves more power than you gave them. Solve both of those at once, you understand modern multi-account identity. Here's the mental model to carry through everything that follows. Once you're past a single account, identity becomes the control plane. It's where security actually happens. And the controls split into 2 families. Some of them grant access. Others can only cap it, only take it away. They never give. Keeping those 2 families straight is the entire game, and it's exactly where people get tangled up. So how do the sandbox developers reach production without a permanent key? That's where STS comes in. The security token service returns a bundle of temporary credentials, an access key, a secret key, and a session token. The important part is that they expire on their own. The default is 1 hour, and you can tune it anywhere from 15 minutes up to 12 hours. The call that hands them to you is AssumeRole, and here's why this matters so much. If one of these tokens leaks, it's worthless in minutes, not months. Think about it like this. A long-lived access key is a house key you cut and hand out. It works forever, right up until you change the locks. A temporary STS credential is a hotel key card. It opens your room, it expires at checkout, and it's dead the moment you walk out the door. When you're choosing between those 2, the key card is almost always the safer default. That leads to a decision rule worth memorizing. When you're staring at a scenario where 2 answers both technically work, the one using temporary credentials through role assumption is almost always the right call over the one that mints a long-lived access key. Same outcome, but one of them leaves a permanent secret lying around and the other doesn't. When the choice is a tie, temporary wins. Now, every role actually carries 2 separate policies, and this trips people up. On the left is the trust policy. It answers, who's allowed to assume this role. It names the trusted principal. It lives on the role in the target account, and it can add conditions we'll get to in a moment. On the right is the permissions policy. It answers what the role can actually do once you're inside it. That's the borrowed set of permissions, scoped to just what the role needs, and fully controlled by the account that owns it. Who can get in, and what they can do once they're in. 2 different questions, 2 different policies. Let's watch Megacorp setup come together. On the left is a sandbox account, account A with the developer inside it. That developer's identity policy grants one thing, permission to call AssumeRole on a specific rollover in production. On the right is the production account, account B, holding a tightly scoped prod role. That role's trust policy says it trusts account A. When the developer calls AssumeRole, production hands back a set of 1-hour credentials. And here's the key idea, both sides must agree. Production has to trust the sandbox, and the sandbox developer has to have permission to make the call. Miss either half, and the whole thing fails. 2 keys, 1 lock. Here's a way to feel what assumption really does. It's like a visitor badge at a partner company. Your own employee ID gets you exactly nowhere inside their building. So you go to the front desk, and they swap it for a temporary visitor badge that only opens the rooms they authorized. At end of day, it deactivates. That's role assumption. You drop your own permissions and borrow a scoped, expiring set from the other account. There's one refinement worth knowing when the caller isn't your own company but an outside vendor. You add an external ID, a shared secret string, as a condition on the role's trust policy. Now only a caller who knows that secret can assume the role. It defends against a sneaky attack called the confused deputy problem, where an attacker tricks a vendor into using its access on your account. So the cue is simple. When a scenario describes a third party or a SaaS vendor needing access to your account, reach for external ID. One catch on those session durations. A role can allow sessions up to 12 hours long. But the moment you chain roles, meaning you assume a role from inside a session that was already assumed, you get hard capped back down to 1 hour, no matter what the role's maximum says. It's a small detail, but it's the kind of thing a scenario will hinge on. Let's lock in what we've got. STS issues short-lived credentials through AssumeRole. Cross-account access needs both sides to agree. A trust policy on the role and an identity policy on the caller. And when answers tie, temporary credentials beat long-lived keys. So far, everything we've discussed grants access. Now let's flip to the other family, the controls that only ever take access away. First up is the Service Control Policy, or SCP. This is an Amazon Web Services Organization's policy that you attach to accounts or to whole organizational units. Think of those as folders of accounts. What it does is set the maximum available permissions for every user and role in those member accounts. That gives you central control across dozens of accounts from one place. But here's the part you cannot forget. An SCP never grants anything. It only caps. The organization's documentation is refreshingly blunt about this. It says no permissions are granted by an SCP. An SCP defines a permission guardrail. It sets limits on the actions your users and roles can perform. That word, guardrail, is the whole idea. A guardrail on a highway doesn't drive your car forward. It just stops you from going off the edge. An SCP works exactly the same way. Here's the picture I want stuck in your head for the rest of this video. Imagine permissions as water filling a room. Identity policies are the faucets. They let water in, they grant. SCPs and the boundaries we'll cover next are the ceiling. The ceiling never adds a single drop of water. It just caps how high the water can rise. And that means if there's no faucet, there's no water, no matter how high the ceiling sits. This is the misconception I most want to correct. And again, the docs say it perfectly. A user without any IAM permission policies has no access, even if the applicable SCPs allow all services and all actions. Read that again. You can have an SCP that allows absolutely everything, and a user under it still has zero access until an identity policy grants something. The permissive guardrail did not open the door. You still need the faucet. 2 exceptions catch people out. First, SCPs do not affect the management account, the payer account at the top of the organization. They only apply to member accounts. That's precisely why security teams keep the management account nearly empty and run their real workloads down in member accounts. Second, SCPs do not restrict service-linked roles, the special roles Amazon Web Services create for themselves. So don't assume an SCP blocks absolutely everything. It has blind spots, and those blind spots show up in scenarios. Now, this second capping tool, the permission boundary, where an SCP covers a whole account, a boundary is a managed policy that sets the maximum permissions for a single user or role. Just one identity, and the rule is an intersection. That identity can do only what both its identity policy and its boundary allow. The identity policy says yes, but the boundary says no. The answer is no. Only actions that stored inside both sets survive. And just like the SCP it caps, it never grants on its own. The IAM documentation lays it out clearly. When you use a policy to set the permissions boundary for a user, it limits a user's permissions but does not provide permissions on its own. The effective permissions are the intersection of both policy types. There's that word again, intersection. Boundary and identity policy. Overlapped, and only the overlap counts. Here's where boundaries really earn their keep, straight from Amazon Web Services' own example. Maria wants to let Jean create IAM users so Jean can help administer the account. But she doesn't want Jean minting super users, including a super user version of himself. So she requires that every user Jean creates must carry a boundary policy. Now when Jean forgets to attach that boundary, the create user call simply fails. He literally cannot build an identity more powerful than his own boundary permits. That's delegation without the risk of self-escalation. And self-escalation is the exact keyword to watch for. Let's put them side by side because this contrast decides answers. An SCP is an organization-wide guardrail applied per account or per OU. It automatically covers every principal and scope, every user, every role, even ones created tomorrow. It scales effortlessly, but it cannot touch the management account. A permission boundary is a per identity cap on one user or one role. You must attach it identity by identity, which means a role someone creates without one is completely unbounded. But it's the perfect tool for delegating IAM safely. Same job, capping, but one is automatic and broad, the other is manual and surgical. One analogy makes the scope difference stick. An SCP is a citywide zoning law. Pass it once and it applies to every building in the district automatically. A permission boundary is a fence you build around one specific yard. It works great, but you have to build a brand new fence for every property. And a yard you forget about? It has no fence at all. That coverage gap is the real operational risk with boundaries. So here's your decision rule, and it's remarkably reliable. When the scenario says across all accounts or central control or an organization-wide guardrail, that points to an SCP. When it says delegate IAM or let developers create roles or cap one specific identity or prevent someone from escalating their own privileges, that points to a permission boundary. That self-escalation phrase almost always signals a boundary. Quick checkpoint. Both CPs and permission boundaries restrict, and neither one grants. The SCP is organization-wide, automatic, applied per account or OU. The boundary is per identity, manual, and it's your escalation prevention tool. Now we shift to a completely different problem, What happens when the thing that needs Amazon Web Services access isn't even inside Amazon Web Services? Let's kill a tempting misconception right now. You cannot attach an IAM role to an on-premises server. Remember the instance profile from the last episode, that container that holds a role? It is EC2 only. It only bolts onto Amazon Web Services instances. So any answer that says attach a role to the on-prem host or assign an instance profile to the on-prem host is describing something that physically cannot exist. It's a distractor dressed up to look reasonable. So what's the real answer? IAM Roles Anywhere. It lets workloads running outside Amazon Web Services obtain temporary Amazon Web Services credentials, on-prem servers, containers, and even applications running on other clouds. Instead of a baked-in key, the workload presents an X.509 certificate and trades it for short-lived credentials. The beautiful part is that no static Amazon Web Services secret ever lives on the external machine. Nothing to leak, nothing to rotate. Here's the flow. Start on the left with the on-prem server, holding an X.509 certificate from your own certificate authority. In the middle sits the trust anchor. That's a reference to your certificate authority, registered with IAM Roles Anywhere, so Amazon Web Services knows to trust it. The server presents its certificate to the trust anchor. And on the right, Amazon Web Services issues temporary credentials in return. The certificate does the vouching, and no long-term Amazon Web Services key ever has to touch that server. It's the guard at the gate checking a contractor's notarized certificate and handing back a temporary expiring pass. The documentation sums it up in one line. Using IAM Roles Anywhere means you don't need to manage long-term Amazon Web Services credentials for workloads running outside of Amazon Web Services. That's the whole pitch. If a scenario has an on-prem box or a non-Amazon Web Services workload that needs to call Amazon Web Services AP is without static keys, this is your answer. And any option that attaches a role or an instance profile to that machine is wrong. Now, let's pull it all together into how one request actually gets decided when an organization is in play. It runs as an ordered gauntlet. First, explicit deny, and any policy, anywhere, ends the request immediately. If nothing denies the organization guardrails, your SCPs have to allow it. Then the resource policy on the target, then the identity policy on the caller, then the permission boundary, that per identity cap, and finally the session policy, which can narrow things further for one session. The request is allowed only if it survives every single one of those layers. The evaluation logic states the dominant rule plainly. If the enforcement code finds even one explicit deny that applies, it returns a final decision of deny, 1. That's it. There is no way to allow around an explicit deny, not with an admin policy, not with anything. So when you're working a scenario, scan every layer for a deny before you ever conclude a request is allowed. That single deny beats every allow on the board. Picture getting into an exclusive event. There's a bouncer holding a banned list. If your name's on it, you're out instantly. No argument, no exceptions. That's the explicit deny. If you're not banned, you still have to clear every checkpoint in order. The venue's master rules, your invitation, your wristband limits. Pass all of them and you're in. Fail any single one, and the night is over. That's exactly how Amazon Web Services evaluates your request. And here's the model that ties the restricting layers together. The docs say an IAM entity can make a request affected by an SCP, a permissions boundary, and an identity-based policy, and the request is allowed only if all three allow it. The effective permissions are the intersection of all three. So even an administrator policy granting star on star still fails the moment an SCP or a boundary above it doesn't include that action. The grant is only ever as wide as the narrowest cap surrounding it. If you remember one slide from this whole video, make it this one. On the left, the things that grant identity-based policies and resource-based policies, these are your faucets. And without at least one of them, there is no access at all. On the right, the things that only restrict service control policies, permission boundaries, and session policies. These never add a drop. They only lower the ceiling. When a scenario implies an SCP or a boundary is giving someone access, that answer is wrong. Full stop. Let's carry 5 rules forward. Temporary credentials through AssumeRole beat long-lived keys. That's your tiebreaker. Identity and resource policies grant, while SCPs, boundaries, and session policies only restrict. Across accounts means SCP. Delegating IAM or capping one identity means permission boundary. On-prem or non-Amazon Web Services compute means IAM Roles Anywhere, never an attached role. And explicit deny anywhere wins, with effective access being the intersection of every layer. Now let's see how well all of that stuck with a quick 5-question quiz. Question 1. Sandbox developers at Megacorp need to read certain production resources, and security insists that no permanent production credential ever leaves the production account. What's the best approach? Option A, create IAM users with access keys in production and share them. Option B, have developers assume a tightly scoped production role through STS AssumeRole to get short-lived credentials. Option C, add the sandbox users as principals directly in every production resource policy. Or option D, generate long-lived keys in production and rotate them every 90 days. Run the tiebreaker before you answer. This one is B. Cross-account AssumeRole hands back temporary, auto-expiring credentials so no permanent production key ever leaves production. The trust policy trusts the sandbox account, and each developer's identity policy allows the call. Every option involving long-lived keys fails the no permanent credentials requirement. Question 2. A member account has an SCP attached that allows all services and all actions. A brand new IAM user in that account has no identity-based policies at all. What can that user do? Option A, nothing until an identity policy grants something. Option B, everything, since the SCP allows it all. Option C, only read-only actions as safe defaults. Or option D, everything except actions on the management account. Lock in your answer before I give it away. The right call here is A, nothing. This is the misconception the exam loves. An SCP never grants. It only caps the ceiling. A permissive SCP with no identity policy still leaves the user with 0 access. Because the grant has to come from an identity or resource policy, no faucet, no water. Question 3. A team lead wants to let developers create their own IAM roles, but must guarantee those developers can never grant a role, or themselves, more than a defined maximum. Which control fits best? Option A, a service control policy on the organization root. Option B, a resource-based policy on each service. Option C, a permission boundary required on every role the developers create. Or option D, an explicit deny in each developer's identity policy. Think about which keyword matters most here. It has to be C, and here's why. The phrase to catch is preventing self-escalation while delegating IAM. That's the signature of a permission boundary. Requiring a boundary on every created role caps those roles to the intersection of their policy and the boundary, so no one can mint something more powerful than the maximum. A cross-accounts language would point to an SCP, but this is per identity delegation. Question 4. An on-premises server needs to call Amazon Web Services APIs regularly, and security has banned storing any long-term Amazon Web Services access keys on it. What's the correct solution? Option A, Attach an IAM role directly to the on-prem server. Option B, assign an EC2 instance profile to the on-prem host. Option C, create an IAA user with access keys and drop them in a config file. Or option D, use IAM Roles Anywhere with a trust anchor and X.509 certificates. Got your pick? Let's see. If you said D, well done. You cannot attach a role or an instance profile to a non-Amazon Web Services machine. Instance profiles are EC2 only, which makes A and B impossible. And storing keys in a config file violates the no long-term keys rule, killing C. IAM Roles Anywhere lets the server trade an X.509 certificate at a registered trust anchor for temporary credentials with nothing static left behind. Question 5. A user's identity policy allows deleting objects from S3, but an SCP on the account explicitly denies all S3 delete actions. The user tries to delete an object. What happens? Option A, allowed because the identity policy grants it. Option B, allowed because SCPs only apply to roles. Option C, denied because an explicit deny in any layer overrides every allow. Or option D, allowed, unless the object has a resource-based policy. Pause here if you want more time. The answer is C, denied. Explicit deny always wins. In the evaluation order, a single explicit deny anywhere, including inside an SCP, ends the request immediately, no matter what the identity policy grants. And no, SCPs apply to both users and roles in member accounts, so B is wrong too. Effective access is the intersection of every layer, and one deny collapses it to nothing. That's a wrap on IAM roles assumed. STS, cross-account access, SCPs, and permission boundaries. Quick 3 things. Subscribe if you want the rest of the Cloud Architect path without hunting for it. Comment what clicks so I know I'm on the right track. And tell me which exam to tackle next. I build the courses people actually ask for. Oh, and if the pacing or the look of these videos could improve, don't be shy. Thanks for studying with me. See you soon.